All right. If 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 you can't see my paper, then just someone speak out. I'm assuming everyone can see this, but here we go. Here we go. 3-8 is called compound inequalities. Now, maybe you've heard this before, maybe you've worked with these before, but compound inequalities are really just two inequalities at once that are joined by the word and or the word or. Okay? Like this double inequality, like this is like two inequalities that are joined with the word and then this one down here below it is a couple inequalities joined by the word or. Now, I don't think I need to go like too much into detail about like what these words just basically mean in general, like in the everyday English language. You know, I want to have, um, like I want to have a hamburger and some chicken McNuggets or chicken nuggets, whatever. That's a different statement than using the word or. Like I want to have a hamburger or chicken nuggets. You know, so the word and the word or, they mean two very different things, just like in general. Aaron's here. All right, so continuing on. So when you have saying that x is less than 4 and x is greater than -1, you know, now you need to graph all the numbers that satisfy both of these at the same time. So everything less than 4 and greater than -1, those two graphs are just going to combine. Because all you really want is the numbers that are in between -1 and 4, right? Less than 4 and greater than -1 at the same time. Now, this over here is another way to say the same thing. I mean, just think about it. -1 is less than x, which at the same time, x is less than 4. This is like saying x is in between -1 and 4, you know? Like, think about it. X is greater than -1, but also less than 4 at the same time. So this is the same exact like compound inequality. It's just that these are like literally separated and they have the word and connecting them. These are just like two inequalities, like the same two inequalities, just kind of smushed together like in this sort of like combined form. And then down here with the word or, see, the word or is a different thing altogether. X is less than 2 or x is greater than 5. You know what I mean? Like you can be this or that and it's all good, you know? So x is less than 2, that's this graph, or x can be greater than 5. So all of like the entirety of both of these graphs, you know, is included in like the final graph, you know. And this is, well, let me just say this, okay? Writing it like this is very, very, very rare, you know, because this is basically the or. So this is the same graph. It's like an or in disguise. If you were to break these up, you would write it as like an or connecting them. But I do want to stress very, very much that this kind of way to write it is very, very rare, which is strange because writing an or compound inequality all smushed together like this, that's very rare. But up here, writing the like smushed version of an and is very, very, very common. Like this is actually very common, okay, to have like an and compound inequality all smushed together like this. So one more quick thing to notice before we turn the page around is that with an and type compound inequality, when the word that's connecting the two of them is technically and, whether it's literally written right here or it's just kind of like behind the scenes an and, look at what the graph looks like. The two graphs sort of run into each other and they just combine for like this in-between thing. But when the word going on is an or, like when you literally see the word or, this is what the graph usually looks like when the graphs are like running away from each other. All right, turn the page. We got 4 quick examples on the back. And then maybe we'll take a peek at the homework and see what happens. All right. So if you notice, what we have here is negative 3 is less than 2x minus 1, which is less than x. Aaron, what word technically is involved here? And or?
Or?
No, it's and. When what you have is like a double less than, just like on the front page where it was like a double less than. See, again, that's what matters. Is it a double less than or is it a double greater than? You know what I mean? Again, this right here, super rare. I don't know if you'll like ever see this, like on the Keystones or like one of my exams or something. So, but again, Aaron and everyone, this is very common. Negative 1 is less than x, which at the same time, x is less than 4. So everything that you could like plug in for x or have x equal to is in between negative 1 and 4. Hence this graph. Because it's like an and. Like you could literally refer this back to like what this is saying. X is less than 4 and at the same time x is greater than negative 1. So if we wanted to, Aaron, we could break this up into 2 separate inequalities. I'll do it up here because you'll just see. Like if you want to write this down with me, then write it up here. You could say negative 3 is less than 2x minus 1 and 2x minus 1 is less than 7. If you separated them into like the 2 separate inequalities, you know, the word would be and these would be the 2 inequalities. Like 2x minus 1 is included in both of them. Negative 3 is less than 2x minus 1 and 2x minus 1 is less than 7, like at the same time. And then what you would do, people, is you would just like solve each of these for x and then graph them both. But guess what? You can solve for x as is. Like the way this is written, you can solve for x. So here's what I'm going to do. I'm going to get x all by itself in the middle. The first thing I'm going to do, like if I wanted to get x all by itself, Jack, in the middle, what's the first thing I'd have to do?
I don't know.
Well, what's in the middle along with x? We got this times 2 and we got this subtracting of 1. We got to get rid of both of them. What do you think, Jack, is the first thing we got to get rid of? Like the 2 or the minus 1?
The minus 1.
Good. So what we're going to do is we're going to add 1 to the middle. We're going to add 1 to the right. And we're going to add 1 to the left. Like that's what we're going to do. Again, I just want to say this one more time. It's the same as what you would do if you were like had 2 separate inequalities and you were solving both of them for x. Like this is essentially what you would do. So now negative 3 plus 1 is negative 2, I believe. See, now it's just 2x in the middle, and the right side is now 8. Okay, Dakaya, what's the next thing we have to do to get x all by itself? This says like 2 times x. So how do we get rid of this 2, Dakaya, do you know?
Can you subtract?
Nope. We got to do the opposite. See, right here we have like 2 times x. That's what this says. We have to do the opposite of that to get rid of it. So that would be dividing. So we're going to divide, and again, you divide the middle by 2. You got to divide all of those, like the right side by 2 and the left side by 2. So we now have x alone in the middle, and over here we're going to have a 4, and over here we're going to have a negative 1. So this is kind of a weird coincidence, but we have like the same, like, so in a way this is like the final answer. But if you needed to graph that, you have to recognize this as, you know, like you're like a typical and, like in between type inequality. Because this is like saying x is greater than negative 1 and less than 4 at the same time. So again, like the two separate inequalities head into each other and they collide. So that's the final graph. Okay? Number 2 looks like it's an OR. And usually with an OR, you're going to have the inequalities already separate. Okay? So we're just going to solve both of these separately. So William, what's the first move to just, again, we're going to just solve these separately and graph them both on the same number line. So William, what do I do to solve this over here for x?
U minus 4.
No. This says 4 times x, and then we're adding 3. The first thing we got to do is we got to cancel out this plus 3, which is we're going to subtract 3. So we get rid of that adding of 3 by subtracting 3. So negative 5 minus 3 is going to be negative 8. Now we cancel out the 4. But since this says 4 times x, now we divide both sides by 4. All right, Connor, what do we do to this one over here?
Five by two, or minus 7, sorry.
I can't hear you over the music there, buddy.
And subtract 7.
Subtract 7 from both sides. Now watch this, everybody. Okay, Connor, you can mute now. So over here, 1 minus 7 is negative 6, correct? I hope I'm correct right now. So then what we have to do is divide both sides by negative 2. Now remember, when you divide both sides by something negative, you have to flip the symbol, right? So x is by itself, the symbol flips to a greater than or equal to, and over here we have a 3. So now we have x is less than or equal to negative 2, okay. Now remember, I have to color in the circle. So less than or equal to negative 2 or greater than or equal to 3. Notice how, first of all, I'm coloring in the circle again, but notice how these graphs are running away from each other. That's the usual thing that happens when it's an OR. Okay? So sort of like to summarize so far, in AND situation, the inequalities are probably already going to be smushed together like this. And you could break it up if you wanted to into like two totally separate inequalities with the word and, but you can just solve for x in the middle, get a final answer like this, and this always just means like a in between, like everything in between -1 and 4. Or like you have an or type situation where usually the inequalities are already two separate inequalities, and you solve each of them separately, and you graph them on the same number line, and the usual thing that happens is the graphs are running away from each other, and like this is your final answer. All right, number 3. What are we going to do here, Aaron? In number 3. Did you say I don't know?
Yeah.
Well, I mean, we have two totally separate inequalities. They're just but they're sort of together because they're connected by the word or. But they're separate. And we're going to solve each of them for x. That's all we're going to do. So, Aaron, what do we got to do here to solve this first one for x? Do you know? Just separately, like just to get x by itself, what do we do?
Divide by 2.
Divide by 2. Yep. So that gets that x by itself. Ooh, -5 divided by 2. That's not clean division. I suppose we could leave it as a fraction, or maybe in this situation, is that the decimal? -2.5, whatever. All right, now we're also going to solve this one separately. All right, so Dakaya, this one over here, 3x plus 1 is greater than or equal to 13. What's the first thing we do to both sides to get x all by itself? Close, really close. We are gonna work on the 1, but we got to do the opposite to get rid of it. So, getting better. We would have to subtract 1. Or maybe I misheard you, I don't know. But we have to subtract 1 from both sides. So 3x now is greater than or equal to 12. All right, what's the next thing, Dakaya? Now to get rid of the 3, what do we do to both sides?
Divide by 2.
Very good. And so x is all by itself, and now we have x is greater than or equal to 4. And the word is or, right? So I'm going to expect that these two graphs are going to run away from each other. Let's see what happens. Less than -2.5. That's like right there. William, should I color in this circle?
No.
Very good. And then it's a less than, so we're shading that way. William, am I going to color in this circle on the 4?
Yeah.
Yeah. And we're shading, let's see, x is greater than, so we're see, I told you. This is what happens like 99% of the time. When the word is or, the graphs are going to be running away from each other. All right, see it now in number 4. In number 4, it's like it's all smushed together, and since it's a less than and then another less than, I know this is less than or equal to technically, but if you broke this up, the word would be, what would the word be, Connor, if I broke these up into two separate ones? Like 0 is less than or equal to x minus 1, and also x minus 1 is less than 4. What word, Connor, would connect these if I broke them up like this?
And?
And. That music makes me think of Street Fighter 2 or something that I used to play when I was a little kid. Good stuff. Yeah, the word is and. So this is like an and in disguise. Again, if you were to like literally break these back up into two separate ones, just like this, the word is and. But I like to get x all by itself, you know, like in the middle here. So how do I get x all by itself in the middle? I got this minus 1 I have to undo. So I'm going to add 1 to the middle, the right, and the left. And so I got someone at the door. Try to graph that in the next couple seconds. I'll be right back. Were you in here yesterday or no?
Yeah.
You're 2 days in a row. I guess tomorrow you're starting back at those back. All right, gang, I'm back. So that didn't take much to get x by itself. All we had to do was like one thing. But again, remember, technically what this says is x is greater than or equal to 1 and x is less than 5. The word is and. So you have to realize that this is like an in-between type situation. Let's see here. We have, what, 1 and 5? So we have 1 and 5. Are we going to color in either of these circles or both of these circles? Looks like the 1, because x is greater than or equal to 1. And so then we just shade in between. So, I mean, that's that. Because again, if you were to break this up, you would have x is greater than or equal to 1. And x is less than 5. You know, look, greater than or equal to 1 and less than 5, like at the same time. So these graphs run into each other, and you just kind of and you only stick with like what's in between for like your final answer. Like you just, what I'm saying is they collide together and they just kind of stop. You know what I mean? And that's like your final graph. So that's it for the notes. I mean, we got and compound inequalities, and then we also have or ones. Let's see if there's any surprises on your homework. All real numbers that are between -4 and 6. So we just want to graph everything that's between -4 and 6. Now, I mean, I'm not going to be a stickler about, like, I think technically we're not supposed to color in -4 and 6, but when you graph everything that's between, you're just coloring in all that, you know? All real numbers that are at least 2. At least 2? What does that mean? Doesn't that mean, like, everything that's greater than or equal to 2, and at most 6. At least 2 and at most. That means like it's at least 2 but at most 6. That's another in-between situation, isn't it? Where like we're less than or equal to 6, but we're also at the same time at least 2, so greater than or equal to 2. Yeah. So there's stuff like that, which I don't think will cause you much problems. And then once you get down to here, looks like you're going to be wanting to like get the variable all by itself in the middle. Let's do number 8 together really quick. Oh my goodness. Number 8? What an ugly problem. The first thing we would have to do, I think, is subtract 3 from both sides. 4 is less than or equal to -2x, which is less than 8. Now we have to divide both sides by -2. Which means we're going to have to reverse. We got to do like a reversal. Okay? We got to do a reversal. Now bear with me here, people. I hear like a dog. Is that a dog or something? Like I feel like a dog, like what's the word? Like moaning in the hallway or something. Anyway, check this out. So what this says is negative 2 is greater than or equal to x, which is greater than negative 4. So it's a greater than. But do you notice, like, we have to put this in order. Like, negative 4 is smaller than negative 2. So how this is really supposed to be written is, check it out. Negative 4, like we're going to write this from right to left. So that's probably like the final way to write it. So this is an and, you know, like this was an and from the get-go. And then you had to like reverse the symbols because you were dividing both sides by something negative. But really, you had to like rewrite this because you want to write the smaller number first. Negative 2 is not the smaller number. Negative 4 is smaller. So when you actually write it the other way, you do see, oh yeah, this is an and we are just going to graph everything between negative 4 and negative 2. With, look, or equal to, so we have to color in negative 2. And then we shade in between. So be on your toes for stuff like that. Dividing the middle, left, and right by something negative. But that just means you're probably going to have to rewrite it again from right to left, just like I did here, okay? A couple minutes. Are there any other like tricky ones on the homework that we can do for free right now while we have the time? I don't know. Same thing might happen here in number 11, people. You're going to end up dividing everything by negative 3 eventually, and then you might have to kind of, yeah, some tricky ones. And then kind of the same thing. So I think right here, people, like it's almost like the homework hits a halfway point where you do your homework sort of like again, but now it's all about or. So 17, 18, 19, and 20, it's probably about or now. All real numbers n that are at most negative 3 or at least 4. Because what does at least 4 mean? Doesn't that mean like at least 4? Doesn't that mean like 4 or more? And at most negative 3, doesn't that mean like you could be less? So again, this is like a classic OR graph where they're running away from each other. And then it looks like a lot of these problems, like starting with 21 and 22, and 23 through 28. You see how you notice how all of these are already broken up into like two separate inequalities? You're just going to like solve each of these separately for x and just graph them both on the same number line, and in all likelihood the graphs are going to be running away from each other like so. Alright, that is, I think that's all there is to know, for, at least for right now, about compound inequalities. If you want to